So as promised, this video will show the solutions to the practice problems I gave in the last video. Basically, after I did each example, I gave one for you to try, and here they are. So hopefully you tried them, especially the second one, because that one, as you can see, is up on the board. Had a little twist in it. So just to go through them as quickly as I can. The problem on the left, 2 tan x plus 1 equals 3 from 0 to 360. I followed the four-step process. I let t equal tan x. That solved the 2t plus 1 equals 3 down to t equals 1. So that got me through step 2 where I isolated the variable. Once t is equal to 1, go back to the trig function to solve for x. So I have tan x equals 1. Tan inverse of 1 is 45. You can get that out of a calculator. That's also one of our table values. So if you're good with your trig values, you would know that without a calculator. Since the calculator gives me 45 degrees, that's my reference angle. The key thing is then realize that there are two answers. There's an answer in quadrant 1 and an answer in quadrant 3 because tan came out positive. Tan x was positive 1. And tan's positive in quadrant 1 and quadrant 3. So the quadrant 1 answer is that reference angle 45. I need to know what 45 degrees looks like in quadrant 3, so I did 180 plus 45, and that gave me 225. So the answers to that were 45 degrees and 225 degrees, and hopefully that's what you got. The second problem I gave involved 4 cosecant x minus 3 equals 0. Now this, it ends up you run into a roadblock because when you get to, well, step 1 is to replace cosecant with x. That eventually gets you down to c equals 3/4. That gets you to cosecant x equals 3/4, which you need to use its reciprocal function. So the reciprocal of cosecant is sine. Flip over the 3/4 to 4/3. Now, if you really understand the unit circle, trig, you'd realize sine and cosine are stuck between -1 and 1. So sine x equaling 4/3 is actually not possible because 4/3 is bigger than 1. 4/3 is 1.3 repeating. There is no such angle that has a sine that's greater than 1. It's not possible. If you realize that, you'd know there was no solution. The calculator will give an error. I don't know if I have my calculator available. Here, it's right here. I'll just show you. I think it just says something like no solution or whatever. Let's find out what it says. So if I do sine inverse of 4/3, there it is. Error in the domain. It basically, there's no such solution. So since there's no solution, the calculator kind of goes a little nuts and goes, well, I can't find an answer. Basically what that tells you is there's no answer. What x value solves that equation? What angle? There are no such angles. No angles fulfill this thing. So you don't actually have to go on. Since there are no solutions, you stop there. There's no reason to convert anything or go any further. So this equation is a bum equation. So that second one had no solution. And here's the last one. This one had exact radian answers. It starts with the equation. I replaced cosecant with c, so that made it simpler to solve. It was 2c plus 4 equaled c plus 6. After some solving, you can see the work. I got to c equals 2. I don't want to leave it as c equals 2. A common mistake in these for students who don't get a lot of the points is they'll solve the equation and then they call it a day. They'll stop right here. You need to realize you need to solve for x. So once you isolate this variable, you got to go back to cosecant x equals 2. If cosecant x equals 2, realize 2 is 2 over 1. So if you want to flip it over, cosecant can turn to sine. Just flip the 2 over 1 into 1/2. Now you can sine inverse 1/2. So it's actually similar to the problem I did. Sine inverse of 1/2 comes out as 30, so the reference angle is 30. Since sine was positive, I should get angles in quadrant 1 and quadrant 2 according to stack. That's where sine's positive. So my quadrant 1 angle is 30. My quadrant 2 angle is 180 minus 30 or 150. If it were a degree problem, that would be done. My problem is it wants radians. So in order to get, where is it over there? In order to get the radian measure, I need to multiply by pi over 180. Since the degrees came out exact, the radians will come out exact. So the radian solutions are pi over 6 and 5 pi over 6. If you're having trouble simplifying, basically that 30 is 30 over 1. When you get to 30 pi over 180, if you want the exact solution, you can enter a fraction into the calculator and leave the pi out. So if I do 30 pi over 180, or sorry, 30 over 180, hopefully that'll adjust so you can see it. I have 30 over 180 in the calculator. If you do that with the fraction button, it'll tell you it's 1/6. So leave the pi out, because if you include the pi, the problem is the calculator, the pi is irrational and it doesn't know what to do with it. It'll turn it automatically into a decimal. So ignore the pi and just put the 30 over 180 in the calculator. Once again, this is really blurry and really bright. It's either blurry or too far away. Anyway, hopefully you can make it out somewhat that I put 30 over 180 in as 1/6. If I put 150 over 180 in, it gives me 5/6. So if you leave the pi out, it'll simplify the fraction for you. If you want the decimal answer, put the pi in. So if I want the decimal answer, I would do 30 pi over 180, and I wouldn't use the fraction. I would just use the regular division bar. And it'll give me that pi over 6 is 0.5235, but the preferable answer, unless someone wants the decimal, is that pi over 6. Okay, so hopefully you tried those three. Those are the three solutions. Try to understand this as best you can, because the next few problems follow this exact same process. It's just the solving of them becomes a little more difficult. Basically, from here on out, step 3 and 4 won't really be any different. Step 1 and 2 will be more complicated. You'll have a more complicated equation to solve. And step 3 and 4 will be similar, but you may end up getting more angles to find. So some of the ones I'll do in the future will actually have possibly 4 solutions instead of 2. All right? But that's enough for now. That actually covers several days of material. So try to get a grasp of this, and then we'll move on to the more difficult stuff. And I promise we're getting near the end of Trig. Until next time.